Let's start with the 29th example. And what is said here in this example? A current I is passed through a silver strip of width D and area of cross section A. So here this is a silver strip. Its width is D and its area of cross section is A, and current is passed through this particular strip, which is I. The number of electron density per unit volume is n. So first we need to find the drift velocity. So as we know very well, current density is nothing but Ne into Vd, that is drift speed, while current density is nothing but current upon area. So as current density is current upon area, so current upon area of cross section is A, Ne Vd. Therefore it is very easy to find Vd, which is I upon NEA. So Vd is equal to I upon NEA. Now second, if the magnetic field exists in the region as shown in figure, what is the average magnetic force on the electron? So here if the magnetic field exists, so the force on electron will be EVB sine theta. The charge is electron. I upon NEA, that is drift speed that we have calculated in part A. Magnetic field is B, while the motion of electron in the wire, the planes are perpendicular, so it is 90 degree. So this is cancelled out, so it will be IB upon NA. Now by Fleming's left hand rule we can also find the direction, or by the cross product you can also find the direction. So by using Fleming's left hand rule, forefinger, that is in the screen, middle finger gives the current which is toward right, the force will be acting in the upward direction. So the electrons are experiencing the force in the upward direction due to this magnetic field. C part, due to magnetic force, the free electrons get accumulated on one side of the conductor along its length. This produces the magnetic force on the electrons, which opposes. So this produces transverse electric field in the conductor, which opposes the magnetic force on the electron. Find the magnitude of electric field which stops further accumulation. So here, due to the upward force, the electrons will get accumulated here. So definitely as on the upper surface of the strip, or on this surface AB of the strip, there is excess of electron. So on this part CD there will be deficiency of electrons, so there will be positive charge, and definitely the electric field or potential difference will get set up here. Okay, so obviously for further accumulation, the force exerted by electric field will be Q into E, that is E into E, and that must be equal to force of this particular magnetic field. This should be equal and opposite to the force of magnetic field. So therefore the electric field required to stop all this will be IB upon NA into E. So this is the electric field which is required to further stop the motion, because to stop the motion the necessary condition is that the electric field must be equal and opposite to the magnetic field force. So I have equated electric field as Q into E, and magnetic force is already given to us IB upon NA, and on solving I have found the electric field here. Second, what will be the potential difference thereof across the width? So as we know very well, potential difference is nothing but integration E dr. So as electric field is uniform, IB upon NAE integration of dr. So dr, integration of dr, where dr is the element of this line, so its width is D, so it will be IB into D upon NAE. So it will be IB into D upon NAE, that is the potential difference developed. Further, the appearance of transverse EMF which current carrying hold, there is Hall effect. Okay, that is the additional information given to us. Okay, the D part can also be solved as when the field is uniform, it will be V by distance between the positive and negative layer of charges. So V will be equal to E into D, and already we have calculated this in the first part, which is IB upon NA into D. So whichever you will find easy, this or this, you can use. Thank you.